Right, we're going to pick up here where we left off from the last video, section P-4. This would be the second day, and we're going to start up here with example 5. It says here the next two formulas show the sums and differences of cubes. Pay special attention to the signs of the terms. So we have some term here u, and that's something to the third power, and then we have some other term here v, that's something else to the third power, and this is a sum. We're adding together two perfect cubes. And we can factor this. And when we factor a sum of cubes, it's going to break down into a binomial, a two-termer, multiplied by a trinomial, a three-termer. And if you just pick up on the little pattern here, these aren't too bad to break down. So our original given was u to the third plus v to the third. Our first term, the binomial, are the same terms but not the third power. We figure out, what we are cubing, and that becomes our first term. So it's u plus v. The signs are the same. And then we have the trinomial afterwards. We take this, whatever u is, and we square it and put it right here at the beginning. And then we take this last term v and we square it and we put it at the very end of the trinomial. And the middle term is just u times v. We multiply them together. Now, they said in the directions here, notice, pay special attention to the signs. If we're doing a sum of cubes, our binomial has the same plus sign, but the first sign in the trinomial switches. If this is a plus, we switch this to a minus. The last sign is always a plus, no matter what. And you'll see it's very, very similar to a difference of cubes. In this next part of the example, we have u to the third minus v to the third. So we are subtracting two cubes. And again, it's a binomial times a trinomial. The binomial is u and v with the same sign, just like we had if it was a plus. Just carry that sign right over. The trinomial is set up almost identical. U squared first, v squared last. The middle term is u times v. And now both of these signs are pluses. Here our binomial had a minus. We switch it just like we did over here and change it to a plus. The last sign is always a plus. Might be a little confused. We'll do a few examples and you'll see that this isn't too bad at all. So we have here in example 5, factor the difference of cubes, x to the third minus 27. And I always think about it as I got something to the third power. So I parenthesize it off and put it to the third, and that is x in there. And then we have minus something else to the third. What is 27? What to the third power? Well, 3. So our u's and v's, so to speak, are x and 3. And I like to write right underneath it, because I just drop these right down. The x comes down, the minus sign comes down, the 3 comes down. And then I set up for my trinomial. The first term squared would be x squared right here at the beginning. My second term is a 3. If I square that, I get 9, and that goes at the very end. My middle term are these multiplied together. 3 times x is 3x. If this is a minus sign, I flip it to a plus here, and the last one is always a plus. Can we factor this any farther? Absolutely not. We're done. Let's see, we got another? Yeah, we got another example here with the sum of cubes, where it is a plus. I'm going to come right under it here, and that's something to the third is y to the third. That'd be y to the third power, plus something else to the third power, to the third power, is 8, and that's got to be a 2. So I'm going to drop right here underneath it. The terms just drop right down also. Y comes down, the plus comes down, the 2 comes down. And then we set up for the trinomial. First term squared is y squared. Last term squared, 2 squared is 4. Middle term are these multiplied together. 2 times y is 2y. We have a plus here. Flip it to the other one for our first sign in the trinomial. That would be a minus. And the last one is always a plus. Can we factor that any farther? Nope. So we're done with that. See, that's not so bad. Number 7, example 7, factor a trinomial. Leading coefficient is a 1. So it's 1x squared, plus or minus some other stuff after it. These aren't so bad. I like to just set up an empty set of parentheses and say, okay, what do I multiply to get x squared? It's got to be x and x. My constant here at the end is a 12. A positive 12. What are the factors of 12? 1 times 12. 2 times 6, 3 times 4, and then we'd repeat 4 times 3. So we're done there. We don't want any of that. They're just flip-flopped. Because this is a plus, the signs are the same, and we want it to add up to -7. Which of these across add up to 7? It's got to be the 3 and the 4. So -3 plus -4 is -7, and -3 times -4 is our plus 12. So our terms are x minus 3 and x minus 4. So when the leading coefficient is not, or is just a 1, just find the factors of that constant at the end and figure out how to set up your middle term. Gets a little trickier when that leading coefficient is not a 1. We got a 2 there now, and that makes these a little bit harder. As long as it's a prime number, it's not bad. 2 is prime. 3, 5, 7, those aren't bad leading coefficients to work with. But it just takes a little more trial and error, a little more, come up with, try one answer, and then tweak it to get it a little bit closer to what we're looking for. So we have, what are the factors of 2? 2 and 1. What are the factors of x squared? X and x. So we got to have a 2x and an x. Now we have here a -15. Well, what are the factors of 15? 1 times 15. 2 doesn't work. Well, 3 times 5. 4 doesn't work, and then we're back to 5. So these numbers have to be either a 1 and a 15 or a 3 and a 5. And when we add it all together, when we FOIL it out, our outers and our inners have to add up to +1. And I like to always think, remember, whatever we put here gets multiplied by 2. So whatever we put here gets doubled. And we're going to double that and then do something with the number here, and it's going to add up to 1. So would I want to put the 15 there and get 2 times 15 is 30? No, that's way too big. Would I want to put the 1 there and the 15 there? Well, it's going to be a big gap between those numbers. So I'm leaning toward the 3 and the 5. And whatever I put here, I get doubled. And I want to add up to 1, so I'm thinking the 3 is going to go there. 3, if the 3 goes there, the 5 has to go there. Now we just got to work on the sign. The sign in the middle is a +1. And this is a minus, so I know the signs are different for sure. Let's see, if I put a plus here and a minus here, I'm going to have my outers and my inners. This would be a -6x and a +5. -6 plus 5 is -1, and I want a +1. So maybe I just got the signs backwards. Maybe I'll make this a minus and this a plus. My outers add up to a +6x. My inners add up to a -5x, and if I add those together, I get my +1x in the middle. So there we go. Those are a little bit harder. You just got to, throw in some numbers and try it out and see if it works. And then if you're close, you might just have to tweak it and move your signs around, or maybe just bounce your numbers around. All right, here next we're going to do factor by grouping. Sometimes polynomials with more than 3 terms can be factored by a method called factoring by grouping. It's not always obvious which terms to group, and sometimes several different groupings might work. So a dead giveaway here is we do have 4 terms. Anything we've done previously in this video or in this section have been 3 terms, and our leading term is usually an x squared. Now we have 4 terms, and it's to the 3rd power. So that's kind of a giveaway that this is probably going to be a factor by grouping problem. And what makes it even a little more difficult, you really got to be careful with the negative signs on these problems. Because when you group stuff off, it's easy. I could just go like this, and that's sort of like I factored this negative out. But if I factored a negative out of this positive, a negative times a negative is a positive. So if I just grouped it off like that, I got to remember I sort of pulled a negative out of there. Well, let's look at it at a slightly different way. I'm going to put parentheses around these and look at them as 2 separate terms. And I'm going to pull out common factors. So out of the first binomial, what can I factor out? Oh, and I missed a squared there. That was an x squared. I can factor out an x squared. If I factor an x squared out of an x to the 3rd, I'm left with x. I factored the x squared out entirely, so there's just a 2 there. What can I factor out of this? Well, 3 and 6 are both divisible by 3, and I'm going to pull the negative out with it. I want my leading term in here to be positive. So I'm going to factor out a -3, and what's left inside? X minus 2. I factored out that negative. So negative times negative is positive. If you are working on one of these and you get these to be the same except for the sign, if I had messed up factoring out that negative, this would be a plus. And I'd think, okay, they're really close, but I got a plus in there. What did I do wrong, or how can I fix it? Just go back and double check your signs. I did have to factor out that negative with the 3. So if I look at this in brackets, underlined in blue are the common term. I can factor out that binomial x minus 2, and then I'll have a binomial left. If I factored these out, what remains is x squared minus 3. X squared minus 3. So there's my two factors. Double check this one. Is this a difference of squares? No, 3 is not a perfect square. So we can stop right there. Example 10. Factoring a trinomial by grouping. They did give us a clue again that it is factor by grouping. And this one is a little harder to see. We only have 3 terms. Squared, first power, and then just a constant. So we might start looking at this problem as trying to break it up. This would be 2x times x. What times what is 2x squared? 2x and x. We might be able to go about it that way and get the right answer, but there is a different way, and this, like I said, it's sometimes harder to see. I got a 2x squared and then a minus 3 at the end. I got this plus 5 here. Do we have to leave that as a plus 5? And this is where, it gets kind of sticky. Another way to write 5 would be plus 6x minus 1x. It's sort of, uncombining. Remember, we collect like terms. If we were simplifying this, I'd say, okay, collect these like terms. Plus 6 and minus 1 is plus 5. This is sort of breaking it apart. And the reason isn't too obvious yet. Now, if I group these off as we've done before and start to factor out common stuff, let's see, 2 and 6 are both divisible by 2. So I can factor out a 2. We have an x squared and an x, so I can pull out that x. And then what's left inside? X plus 3. Ooh, and that's pretty darn close to what we have in the second set of parentheses, minus x minus 3. So if we factor out just the negative, pull out a negative, we're left with 1x plus 3. And, let's even say we pulled that one out there. Now, and we can, sort of bracket that off in our heads. We have an x plus 3 and an x plus 3 term that comes out, x plus 3. What is left inside? We still have a 2x and a minus 1. 2x minus 1. So that, that's a little harder to see there and breaking that plus 6 or that plus 5 up into a plus 6 minus 1. Again, when I first look at that problem, if the directions didn't say factor by grouping, use grouping by factor to factor this, then I would have just went after the the leading coefficient not being a 1. 2x squared has to be 2x times x. We have 3, that's a prime number. It's got to be a 3 and a 1. And then I'd have to figure out, okay, does the 3 go here and the 1 go here, or vice versa. With a little trial and error, we'd get the exact same answer. But because the directions did say factor by grouping, I wanted to factor by grouping. And we had to bust that plus 5 up. So here's some guidelines for factoring polynomials. Step 1, pull out any common factor you can, the reverse of that distributive property. Step 2, factor according to one of the special polynomial forms. If you have a leading coefficient bigger, bust it up. Or if it's got 4 terms especially, you're probably going to have to do factor by grouping. So now for some fun, a few practice problems here. We got a difference of cubes, a sum of cubes, leading coefficients not 1. The last one is factor by grouping. So pause the video, try the problems, start her back up, and see how you did. Alright, I like these difference of cubes. So x to the third has to be x to the third power. What to the third power is 8. That's got to be a 2. So there's our terms. Bring them right down, x minus 2. And then we set up our trinomial. First term squared at the front. Last term squared at the back. Middle term are those multiplied together. 2 times x is 2x. Here's a minus sign, so we put a plus. Last term is always a plus, no matter what. All right. 47. Another sum of cubes now. So we have y to the third. What to the third power is 64. That's got to be a 4. So our first term is our binomial, y plus 4. And then we set up our trinomial. First term squared, last term squared. Middle term is those multiplied together for y. If we have a leading plus here, switch it to a minus. Last sign is always plus. Now it's just factor the trinomial. It's nice, our 3 is a prime number, our constant 2 is a prime number. So we're just going to have to, worry most about the signs here. So 3x squared is 3x times x. 2 has got to be 2 and 1. And since this is a minus and this is a plus, I know both my signs are going to be minuses. So it's not even the signs here. Does the 2 go here or here is the question. Let's try it this way. Our outers would be 3x, and our inners would be minus 2x, and 3 minus 2 is 1. So that's not it. Let's switch those around. So let's put the 1 here and the 2 here, because whatever we put here gets multiplied by the 3. So now that's minus 6x and minus 1x. That's not it either. Oh, no, we did have it right the first time. I just forgot my sign. We had this, yeah, that was a 2 and that was a 1. So that is minus 3x and minus 2x. Yeah, that was the right one the first time. So there's our minus 5x. Why didn't you stop me? So 3x minus 2 and x minus 1 are the binomials when we factored it down. Last one, 73. Factor by grouping. So 2x to the third minus x squared minus 6x plus 3. Again, this is a minus, so you've got to be extra careful. I look at it this way. What can I factor out here? Well, I can pull out an x squared, and then you're left with what? 2x minus 1. We had an x squared, we factored it all out, but we need a placeholder. If I wanted to distribute, x squared times 2x would be 2x to the third. X squared times minus 1 would be minus x squared. That 1 is our placeholder. Here we have minus 6 and a plus 3. I am going to factor out the minus, and the common factor of 6 and 3 is 3. So minus 6 divided by minus 3 is 2, and we have our x. And we had a 3, and we factored out a negative 3, so we're left with a minus 1. And again, these now match up. 2x minus 1 and 2x minus 1. So let me work with a little more room here. And we imagine all of this in a set of brackets, and I can pull out that parenthesis, that 2x minus 1, and then what's left inside. When I factored these out, I'm left with x squared minus 3. X squared minus 3. And neither of those are further factorable. So there we go. That's the end of P4 factoring. The homework problems, careful now, there's some even ones in here. I used a lot of odd ones in the examples and stuff. So try these problems, extra careful with the even ones.